Here is the 4.2, which is now testing you on electromagnetic radiation. It says listed below is information for two different types of electromagnetic radiations. So we've got radiation 1, where they've given us a frequency of 8 times 10 to the power 15 hertz. And radiation 2, we are given wavelength of 7.5 times 10 to the minus 5 meters. Now they want you to calculate the frequency of radiation 2, seeing that we have only wavelength. And we need to get frequency. This can actually be done since we know that electromagnetic radiation travels at the speed of light. So the formula we're going to use is C is equal to frequency times lambda. Now on the left hand side, we are going to replace C, which is your speed of light. That is 3 times 10 to the power 8. Frequency is unknown, and lambda is given as 7.5 times 10 to the minus 5. To solve for f, all we have to do is divide both sides by this value, 7.5 times 10 to the minus 5, and we get frequency as 4 times 10 to the power 12 hertz. Now for 4.2.2, we need to determine the energy of a photon in radiation 1. So we're actually given frequency for radiation 1, and to calculate energy using frequency, our formula is E is equal to HF. So energy is equal to, remember, H is Planck's constant. So if you forget this value, it will be on your table of constants at the back of your exam. It is 6.3 times 10 to the minus 34. And the frequency here that was given is 8 times 10 to the power 5. Okay, all we have to do is put this on the calculator. And let's see what we get. 5.304, so it'll be 5.30 times 10 to the power negative 18 joules. So that would be the energy of the photon for radiation 1. So 4.2.3 and 4.2.4 are application questions. It says which radiation has a higher penetrating ability. Now for penetrating ability, it's best if we look at frequency values. And just referring to the frequency here for radiation 1, we've got 8 times 10 to the power 15, while for radiation 2, we had 4 times 10 to the power 12. Now when we compare these two frequencies together, we notice that the radiation for the frequency for radiation 1 is higher. And how do we know this? Or how do we do this? When we have values in scientific notation, like what we have here, and also what we have here, if we're trying to match and see which is the bigger value, we look at the times 10 part. Specifically, we look at the exponent. So radiation 2, the exponent is 12, and for radiation 1, the exponent is 15. The one with the bigger exponent, that is the higher value. So radiation 1 has a higher frequency, and electromagnetic radiations, the higher the frequency, the higher the penetrating ability. So our answer here is going to be radiation 1. Let's write that down. So how does this actually work? We said a higher frequency has a higher penetrating ability. But how is frequency linked to penetrating ability? Remember, the higher the energy of a radiation, or the higher the frequency of a radiation, the higher its energy. So we're going to start off by saying a higher frequency results in a higher energy of a photon, and therefore a higher penetrating ability. Now let's look at 4.2.4. The frequency of radiation 1 is halved. Will the wavelength of this radiation increase, decrease, or remain the same? And give reason for your answer. So the main thing you need to remember is that frequency and wavelength are inversely proportional. If we are going to halve the frequency, basically you're dividing the frequency by 2. What's going to happen to the wavelength? It's going to be multiplied by 2. So if it's going to be multiplied, then obviously it is going to increase. If frequency is decreasing, wavelength is going to increase. So since frequency decreasing caused wavelength to increase, we know that their relationship is that they are inversely proportional. So that's going to be our reason. Wavelength and frequency are inversely proportional. We are now on to question 5, and this is now testing you on electrostatics. 5.1 says, an uncharged glass rod is rubbed with a silk cloth, resulting in the rod becoming positively charged. Explain how the rod becomes positively charged. So, to understand what's going on here, the rod initially was uncharged, meaning that it was neutral. But suddenly after rubbing it, it has become positively charged. So what happened to its electrons? That would mean that its electrons were transferred to the silk cloth. So it went from having a charge of 0 to now having a positive charge. Initially, when it was uncharged, its positives and negatives were equal. Now all of its electrons have transferred to the silk cloth. So here we have it, electrons were transferred from the rod to the silk cloth. Now we have some information. It says in the diagram below, the positively charged rod is now held to the left of a neutral sphere, suspended by a light insulated string, causing the sphere to move. So 5.1.2 says define the term polarization in words. Now just to explain this, before I give you the definition, what happens in polarization is your charges separate. Remember, objects have two types of charges. They've got positive and they've got negative. And in a neutral object, in a neutrally charged object, which is seen as an uncharged object, there's an even distribution of these positives and negatives, which allows it to be uncharged. But what happens when it becomes polarized is all of the positives move to one end and the negatives move to the opposite end. So here is the definition. It is the partial or complete polar separation of positive and negative electric charge in a system. Basically what happens is it causes all of your protons and your electrons to separate. So they move to opposite ends of the object.